Okay, question 10. Given quadrilateral ABCD with A at 0, 1, B at 1, 0, C at 0, -1, and D at -1, 0. Prove that quadrilateral ABCD is a rhombus. Read the following proof for this column carefully and then answer the questions. Okay, so here's our proofs. This is how I would answer it. I would go to the blank one. Since it's a reason, I would look at the statement. So distance of AB is equal to the square root of 2. Distance of BC is equal to the square root of 2. Distance of CD is equal to the square root of 2. And distance of AD is equal to the square root of 2. Since it's listing that the distances of those side lengths are square root of 2, blank one has to be the distance formula. So I'm looking for blank one, distance formula. All right, blank 2 is clear at the bottom. Quadrilateral ABCD is a rhombus, so that doesn't really give me a lot to go off of for the reason. So I'm going to scan up to the next statement. It says segment AB is congruent to segment BC, which is congruent to segment CD, which is congruent to segment AD. And then I'm going to ask myself, well, what does that mean? It's saying that each of these side lengths, AB, is going to be the same distance from B to C, which is the same distance from C to D, which is the same distance from D to A. So they're all the same distance. So for blank 2, I would look for something that says it's not a parallelogram because we're wanting it to be a rhombus. So it's not the definition of distance. We already used that for blank 1. Blank 2 is not a distance formula. Blank 2 is not Pythagorean theorem. They did not use a squared plus b squared equals c squared in there. It has to support the statement that quadrilateral ABCD is a rhombus. So it is not because of the symmetric property. Blank 2, if diagonals of a parallelogram bisect each other, then it's a rhombus. No, it's saying definition of rhombus. So I'm going to check that against my key terms. So if I select a rhombus, it says a quadrilateral with 4 congruent sides. They just proved that each of those sides are congruent, so it is by definition a rhombus. So that's how I would use the key terms to help me fill in what blank 2 is, as well as the previous work that they were using in statement 4 to solve this. So I hope that helps.